All right, I'm back again. Sorry about the disruption. Hopefully it wasn't a pain to go from one video to another. Okay, now that you have your values, you have your formula, go ahead and see if you can pause and try this. And I'm going to go ahead and pause and then play and see how you did. All right, tangent of A is negative 3/4. Tangent of B, change this back, is negative 15/8. Doesn't matter where you put the negative. It's not specifically associated with the 3 or the 4. And then we're going to just multiply those two values. Because this is a complex fraction, I can get rid of the numerators, but first I'm going to multiply that denominator. So when I multiply negative 3 and negative 15, I get positive 45. Again, that's a complex fraction, so what I'm going to do is I'm going to get rid of all those denominators. Notice that if I'm multiplying a fraction by it, I'm careful to put it in the numerator. That way I know it cancels. Like for this one right here, 32 divided by 4 is 8. Again, see how I'm writing it in the numerator. Okay. So what we get is negative 24, 8 times negative 3. Negative 60, 15, negative 15 times 4. And those just canceled. So I'm getting negative 84 over negative 13. And because they're both negative, it does become positive. There we go. All right. Let's try the last one. So why don't you try to pause and see if you can start from beginning to end, and then push play whenever you're ready. Just copying this formula. You can redraw your triangles if you like, but you should have them on your paper from the previous problems. So tangent was negative 3/4. Oops. Minus in this case. And negative 15/8. I'm going to multiply those two. You can see right away those in the numerator are going to become a positive, that minus in the negative. All right, so let's just clean it up before we get rid of the fractions. And positive 45 over 32. All right, again, because this is a complex fraction, let's multiply everything by 32. That will get rid of those fractions. And since I'm multiplying every term by 32, it would work. So it's negative 24 plus 60, 32, and 45. I'm getting 36 over 77. Let me verify that that is right. Yep, that is right. All right. So the last part's the quadrants A and B. That looks a little crazy, but I'm going to show you how to do part E, and then you can try part F, pause and check. Okay? So rather than look at the requirements they gave us for A and B in the beginning, I want to know, what did we get for sine of A plus B? The actual value, the numerical value isn't important, it's the sign. From this, don't we know that sine is negative, not in quadrant 1 or in quadrant 2? So it would have to be either quadrant 3 or 4. We also found the tangent of a plus b, which was 84/13. Again, the numbers aren't important, but it's positive. That would have to be, that couldn't be here in the quadrant 4. It would have to be in quadrant 3 because tangent is positive and everything else is negative. So pause and see if you can do the same for quadrant A minus B. Sine of A minus B was 36/85. Positive, so that means it couldn't be quadrants 3 or 4. Everything's positive in quadrant 1. Sine is positive in quadrant 2. And then we found tangent of A minus B. And that was positive 36/77. That cannot be here. Tangent would be negative in that quadrant, so that would be quadrant 1. Nice. Number 14, I want you to reference your word wall. Arc sine, or sine inverse, is the inverse of the sine. So the domain and range are actually switched from the sine. So the domain for the arc sine is the same as the range for sine. Now the range for sine, for arc sine, has to be limited, otherwise it's not 1-to-1. Okay, real quick. When we did the sine graph, here it'd be 1-to-1, but as soon as we start to come down, that would ruin the 1-to-1, which, remember, that's for the horizontal line test. So what we did was we made it, we only looked here, which is positive pi/2 to negative pi/2. Okay? It's just an explanation. You could just look it up on your word wall. All right, looking at, and the ends are included. When we look at the graph of the arc inverse sine, it looks like this, and it is definitely increasing. Again, just reference your word wall. And then for this part D part, -2, this is the domain for the arc sine, and it is not included in the domain. Okay, only goes 1 to -1, -1-to-1. All right, so looking at the next problem, let's solve for sine theta. -2 is equal to 0. So first thing I want to do is I want to isolate sine theta. Still not isolated. Let's divide by 4. So sine of theta is equal to 1/2. And they asked us here to look on the unit circle. Where on the unit circle, 0 to 2 pi, does sine equal 1/2? It's positive, so you can check quadrant 1. That's where you get pi/6. And then you can check quadrant 2, and that's 5 pi/6. You would only select option B if there was no answer, but there is an answer. All right, for number 16, I'm going to show you how to solve that analytically. That just means algebraically or by hand. But I wanted to show you what Desmos would look like. They give you the windows to use. So this is how I included it in Desmos. When I typed in tangent, I used functions. I typed in x, and then I had to back arrow to put that squared in. And then you'll see over here when you click the wrench, that is where you can determine the domain and range. And somebody in class told me we could just type in pi for pi. I think there's another way to get it, but typing pi was so much faster. And then the range. So once you do all of that, this is what your graph looks like. Okay, which allows you to answer part A. Now, before I go, actually, no. So the graph looks like this. Okay. Let's solve this analytically. So let's set this equal to 0. So let's add 3. We have to square root, but when we introduce the square root, we must include plus or minus. So tangent of x could equal to positive or negative radical 3. So what I want to do is I want to focus in the first quadrant. What value would give me this? And when I look at pi over 3, I see that the point at pi over 3 is this. And I'm going to do sine over cosine. I know it can't be the 45s because those are identical values, radical 2 over 2, radical 2 over 2. That would make a 1. But this, I think, is going to work. So remember that tangent is sine over cosine. So the sine value goes on top. So I'm going to multiply by the reciprocal. Remember, to reciprocal. And do you see what happens is the 2's cancel. And this would give us radical 3. So this works. Because it could be positive or negative, we're going to find all 4 points, okay, one in each quadrant, where the cosine is either positive or negative 1/2, and the sine is positive or negative radical 3 over 2. Someone in class noticed that if you have the same denominators, you can ignore them because of this reciprocal flipping cancel thing. And then the tangent would be square root of 3 over 1. That's just a little shortcut that they noticed. So in quadrant 1, the point that has those values is pi over 3. In quadrant 2, it's 2 pi over 3. In quadrant 3, 4 pi over 3. And quadrant 4, it's 5 pi over 3. This is where it equals 0. So when I come to my Desmos graphs, what that tells me is that this point right here is pi over 3. This point is 2 pi over 3. This one, 5 pi, oops, not 5 pi, 4 pi. And 5 pi over 3. Those are the zeros, okay? Desmos will not give you that, so that's why you had to solve analytically. Now, for the next part, which is, so for the solution set, for the solution set, here was my answer. That goes there. Part B, got the graph. So now we're looking at the next one. Find the correct solution to f of x is greater than 0. I'm going to use this graph just because it's a little cleaner. So f of x greater than 0 would be anywhere the graph is above the x-axis. So that would be here, here, anything above the x-axis. The next part actually asks for less than 0. So while I'm here, I'm going to go ahead and highlight that in a different color. Almost looks like the rest of the graph, like the color of the graph. because neither of these have equals on them. All these points would be open circles, okay? One more thing to consider is that there's an asymptote here and here, okay? So when we're looking at where is the correct solution for greater than 0, D does not make sense. The entire graph is not above the x-axis, nor is it a collection of, those are the zeros. Between A and B, I can tell A does not make sense. This point right here, 0, oops, there we go, is not part of the graph, so that doesn't make sense, okay? So let's see if A makes sense. So it's pi over 3, which makes sense because that's this point. And it goes up. That probably means the asymptote's at pi over 2. Okay, and then pi over 2 to 2 pi over 3. That's this part. And then 4 pi over 3, that's my next 0. Oops. Oh dear. There. There and there. So definitely my answer is A. For less than 0, let me erase all that. For less than 0, let's start eliminating some that don't make a ton of sense. So the whole thing is not above the x or below, neither is it just points. So it's either A or D. Now, when I look, again, I don't want to switch to the screen again. That whole portion right there is below the x-axis, okay? So it does not start at pi over 3. That doesn't make sense. Whoops. That doesn't make sense. So the answer choice is D, and I know I've cut it off here. Sorry, try to get the whole problem on one. This is what the first interval actually says. 0 is included. Why? Because 0 is right here. It is not on the x-axis. Oops. There. So it actually is able to use a bracket because it's not an open circle. Pi over 3 would be an open circle because it's right there. Okay. Oops, not D. It's part D. All right, I think I'm done. And then I'll send out a link for the Zoom. I hope this was helpful. Bye, guys.